Okay, this doesn't involve a circuit build, but this is another little constant current source that's actually off ESP's website, Elliot Sound Products, and you can see what the link to it is here, if you want to read the whole thing. This he's using as an LED power driver, and he's targeting a limit of like 300 milliamps. But he makes his regulator adjustable, and he does it with resistors in kind of an interesting way. And again, you might find this useful, but it's not going to be useful as a general like test bench current source, because it's not, you're going to have a hard time getting it adjustable over a very large range of currents, unlike the previous video with the 317 I showed you, that involve the transistor here. This one is much more versatile, but you're going to have to, like I said, sort the components out to get it to work properly as a bench supply. But this one's, remember, one thing you got to know about a 317 regulator is the difference between its output and its adjust terminal is always going to be 1.25 volts. So it's always got to be 1.25 volts. If not, it'll just peg itself to the power supply rail. It'll, and that's why it can be dangerous if something, you made it use the 317 regulator, something goes wrong with your, your adjustment network, well, it can fry your circuit with the power supply rails. So there is that, and a lot of supplies like this, they'll have a weak point like that, a lot of different regulators do. So 317 is by no means unique to that. And how probable that is, I couldn't tell you, but I've never had it happen to me, but that doesn't mean it won't happen to you. But I mean, I wouldn't worry too much about it, but I'm just saying, especially if you're basing off a potentiometer, and what if your potentiometer starts giving out? It might not make good resistance. A typical 317 adjustment circuit would, be like a, 120 ohm resistor, from the output to the adjust terminal, and then a potentiometer going to ground. Well, if that potentiometer starts wearing out, its wiper starts, even if it just doesn't make continuous contact over that range, yeah, this thing can jump up to the supply rail, because that's what it'll try to do. It'll think that, shit, or my voltage is, dropped to nothing. Well, let me, up my output so I can try to get my 1.25 volts back. So, I mean, there are cautions like that when you're making an adjustable power supply based on a 317 regulator, or any regulator. There's a lot of different designs, where something like that may happen. And it's not a bad idea to put some kind of a, a reference resistor, if you can, that, across that pot to at least try to contain the damage. But, it's something to take seriously, because really a worn out potentiometer, or just a low quality potentiometer, you could end up frying your load. You just could, and that's why it's not a bad idea to put some output capacitors on it to, to at least compensate for minor variations that may occur as you adjust the pot. So, there is that, and I don't think I've ever actually heard that issue addressed, but really, as I make this video, I start to think about that. I mean, yeah, that could kind of suck. If you had something that was sensitive, like a bunch of logic circuits or something on there, and Arduino's hooked to it, or some shit, and then, you're adjusting the voltage around, and, next thing you know, you got a dead circuit. That's, it's just something to take into account, because these things will float high if something happens to the adjustment terminal's reference to ground. So, they will float high. And this is, using 317 as a constant current source is a great example of doing that. Because that's what it'll do. When you don't have a load on this thing, no power flows through it, but once you, hook, well, I'm on the wrong circuit here. But yeah, once you, even this circuit I built, once you hook a load to it, at first, you've got the full supply rail across the thing, and it'll take it a few seconds to adjust itself down to your load. All constant current sources have that issue. In fact, I burn out more than a few LEDs in my time by, hooking it to a constant current source live and then having it zap the LED because, there's like, I'm hooking up to a 24 volt source but with one LED load, but briefly there's a much higher voltage there, and yeah, it can cook some LEDs that aren't hardy enough to resist that initial surge. So, particularly ESD sensitive LEDs like blue and white, tend to, and green, tend to have issues like that. So it's something to be aware of. But all regulators, work like that. Now, if you have a properly functioning 317 circuit, just conventional, set up as an adjustable regulator, like this one here, it's got that's a 317 in disguise. But this is a conventional circuit. If something goes wrong with that wiper, this motherfucker will go up to your VN supply rail minus its, its, its dropout voltage. So yeah, I mean, you could, if you got it hooked up to a 20 volt supply or whatever, if something goes wrong with this as you're adjusting it, even just temporarily, yeah, you could be applying like, let's say you had 30 volts and you had a 5 volt circuit. Well, you could be applying some, 28 volt spikes to it, as you adjust your potentiometer if you're not careful. And like I said, it's hard to actually come up with a safety resistor because that defeats your, your adjustable resistor to some extent. Because you can do it, but that'll limit your ultimate adjustment range. So, so it's kind of a complicated thing, but it's something to think about. If you're thinking about making an adjustable bench supply, it really is something to think about. So, and I'm not going to say I've never made a mistake like that in my designs. In fact, that could be a little time bomb in some of the power supplies I built waiting to get me. So anyway, but it's just something to take into account, basically. It's sage advice. But at any rate, back to the circuit at hand. This thing, works, like I said, it always has to have a 1.25 volt drop across it, right? Now he's got this resistor, so he can actually adjust the reference to a fraction of the range of voltage that's dropped across this resistor here. Now, so if he has this thing all the way over, I wish this stupid hand wasn't white. Thank you, Microsoft, you bunch of idiots. But if you can, I bet you I wouldn't have that problem if I found the original article, huh? But if you adjust the wiper all the way over to where, basically this 3K resistance is, fully dropping the same voltage across it as our R1 is here, then basically the maximum current that's going to flow out of that circuit is, 1.25 volts divided by 4.7 ohms. So you got 1.25, and that doesn't matter what your input voltage is at all. It's completely independent. And that'll give you about 265 milliamps right there. Now, so that is the minimum current this will put out. So if I adjust this reference terminal all the way to the center here, to where you basically have a 1 to 2 voltage divider here, so it's 3K total, and you got 1K here, but 1.25 volts is going to be dropped across this 2.2K resistor because that's your reference. Now what that allows to happen is it allows the voltage across R1 to increase above 1.25 volts, by about a 1 to 3 ratio. So in other words, by doing that and making that adjustment, you can get up to, for example, 300 milliamps like he's targeting, in that neck of the woods, if you put that right there. So that's the maximum current this will put out. However, if you, instead of having R2, and you should always have an R2 in a circuit like this, instead of having it at 2.2K, you could put it at, like 220 ohms and keep this the same. Then you could actually get even more current out of the circuit. But the consequence is, so let's say this was a 10 to 1 ratio, when you set your little, wiper towards the middle between those two resistors there. Basically, this can develop, like 12 volts across it, for example, just with no calculations, just right off the top of my head, it'll be something like that. So you're choking your load out when you do that. That's why it makes a terrible constant current source. Yeah, you can get, for bench purposes, you can get, more current out of it, but you can never get less current out than that 265 milliamps. Now you can put a bigger resistor here, like 100 ohms instead, but that's going to limit your maximum current because you'll choke your supply out. So, I mean, for example, your minimum current, if I did that, would be 1.25 divided by 100, it would be about 12.5 milliamps. But, we can get significantly more current out of it, because at 12.5 milliamps, it will have only 1.25 volts across R1. But, if I set that wiper like I was talking about, that resistance arrangement I was talking about, yeah, you can get more current out of it, but it'll get a lot more voltage dropped across R1. So again, it'll start choking your source out depending on what your input voltage is. It just doesn't leave you a lot of versatility, but, it's probably true that, if you're going to get 10 times that current, like 122 milliamps out of it, that if it works that way, it may be more nonlinear. Again, I'm not doing the math right now. I'm just off the top of my head doing this. But you're going to be limited to how much current. And do your own math, by the way. This is just off the top of my head. Again, sometimes these things may not work the way I'm just initially seeing them, but it does work this way in general. So, but the exact numbers are off. I'm pulling them out of my ass, so I'm not, working on a calculator. Because it's all, it's all a matter of voltage fractions, and you can work out, okay, let's say we used 100 ohms here, 100 ohms there, and we kept that at 1K. That should be, a 10 to 1 voltage divider. So in order to get that at 1.25 volts, how many volts would have to be across R1? That's the question you ask yourself. All right. So, if that wiper were in the middle, that's the extreme. If the wiper is on over here, it's going to be 1.25 volts, but in the middle, it's going to be 1.25 volts across our 100 ohm resistor, period. So, so that gives you, some idea, but in order to achieve that, you got to have a hell of a lot more voltage dropped across VR1. So, in order to make that only 1.25 volts, and so yeah, you're going to get a lot more current out of it, but but it's going to be, limited. So that's what I'm saying. This isn't the best. It's a great little source to do something like he's doing with it, but it's not a good, like, bench unit. But I still thought it was worthwhile mentioning this and discussing it a little bit. And but like I said, you can find this in his regulators articles on Elliot Sound Products. If you want to read more, there's a bunch of good shit there. So anyway, cheers.